Hi everyone, welcome to the presentation of JDBC. We have titled it Simply JDBC. The reason is it's relatively simple, or it's quite easy to understand how the database connectivity works using JDBC. So let's now proceed. In the previous presentation we have seen about the different types of drivers. Now we'll go into little bit details about each of those types. So let's start with the type 1. So type 1 stands with JDBC-ODBC bridge driver. So let's try to see a diagram. So you can see on the left hand side, you can see here there is a Java application which is going to make use of JDBC call, and in that it's going to invoke JDBC-ODBC bridge driver. So it's going to be a piece of software, this bridge driver is. Now this is going to make native ODBC call because it's going to rely on the older technology, that is ODBC. So it's going to rely on ODBC driver, and then ODBC in turn is going to make call to the database server using native DBMS specific calls. So this is what is highlighted now. So JDBC-ODBC bridge driver uses ODBC driver to connect to the database. So that's about the first point. The second point is about JDBC-ODBC bridge driver converts JDBC method calls into the ODBC function call, and this is what basically is one of the important issue, and we'll see that as a part of it disadvantages also. This is discouraged because as we proceeded, or as the evolution of different driver types have happened, so when it comes to the further drivers, like for example pure Java driver or thin driver, this type 1 driver is really discouraged. What were the issues with it? The issue was basically there was a conversion that was happening. That means the performance was poor because the JDBC method calls were there which were converted into the ODBC function call. So you can see this as a part of the bullet, as part of the disadvantage. Then there was another issue, was that this ODBC driver needs to be installed on the client machine. So essentially this was a full monolithic one. The ODBC driver itself was installed on the client machine. The Java application was also installed on the client machine. So the database, so everything was on the same machine, single machine, and it was a monolithic one. So obviously in the previous versions of Java, like say for example when people were doing Java 2 and stuff like that, so essentially at that time people were using this type of drivers, that where it was type 1 JDBC-ODBC bridge driver. Now let's go into the next driver, which is called as native API driver, and it's a type 2. So here again we can see on the left hand side you have this Java application. This will make a JDBC call, and then it is going to rely on a native API driver. Now this native API driver is going to make a native call to a vendor database library. Now you can see this vendor database library, or this particular component comes into picture and also could form a bottleneck. So let's see the details, and then this vendor database library will using this we will be interacting with the database, and everything has to be on a single client machine. So this used to make use of Java native interface, and those native calls were basically written in C and C++, and so it was partially Java driver, it was not completely Java driver. Then it was obviously faster as compared to type 1 driver, because the ODBC now is no more part of it, but it was depending on the specific native call. The disadvantages was the native driver needs to be installed on each client machine, so that was a disadvantage. And another disadvantage is vendor client library needs to be installed on the client machine. So obviously here the issue was you are going to have, though it is faster compared to the type 1 driver, but again the dependency and the situation is more or less similar to the type 1 driver, where it's going to be a monolithic, like you need to have both the things, that is vendor client library as well as the native driver has to be on the client machine. So this was in a way the disadvantages. Now let's go to the type 3. So this is called as network protocol driver. Now in this the Java application will make again JDBC call. As you can see, the Java application will always make JDBC call to any particular type of driver. Earlier it was making type 1, then type 2, now here it is type 3. Then in this situation of type 3 there is going to be a middleware layer, which is called as which could be called as a server driver, or it could be called as middleware server, and then this will in turn will convert and will do a call to the native database call. So here type 3 driver is going to make a server specific call. So as I was mentioning to you, so it's going to rely on a middleware, something called as application server, and now which will convert the JDBC calls into the vendor specific database protocol. So it is written in Java. Okay, so this is again a little bit of overhead. Then obviously now there is a server layer that is coming into picture. So there is no client side library required as was the case with type 2, and then this server itself can do a lot of things because it's now a quite application server or a middleware it is typically called as. So it can do multiple tasks like auditing, logging, etc. What are the disadvantages? Here you are going to require network support on the client machine. So if you do not have a network support, then you cannot rely or you cannot use type 3. Then it requires database specific coding to be done in the middle tier. So obviously because of this, the maintenance of middle layer or the network protocol driver becomes costly, and it is not that simple, because it requires database specific coding to be done in the middle tier. That means the maintenance is an issue. So for example, you want to talk to Oracle, or you want to talk to MySQL, or you want to talk to say other MS SQL server and all that. So those database specific coding is required as part of middleware server. But the advantage of all this thing is like you don't have that dependency, or it's not a monolithic architecture, and now you can have a database server which can reside on another machine. Let's go to the type 4 now, so which is called as thin driver, or it is called as pure Java driver. So here what will happen is the Java application will again make a JDBC call to type 4 driver. Then type 4 driver will directly make database specific call. There is no middleware layer or some such thing happening. It will directly talk to the database server. Now the beauty is that this driver, which is a type 4 driver, it interacts directly with database. It does not require any database library, and it is also known as a thin driver. It is also called as pure Java driver because completely it is written in Java. Now how is it going to work? So it's going to basically rely on vendor specific database protocol, and all the implementation will be done via socket connection. So that's why this is a pure Java driver, or it's completely written in Java, and Java basically can do socket programming. So basically the internals of it relies on the socket connection. Then the major issue used to come was like what software is installed on client side, like what software is required to be installed on client side, like say for example library or whatever. So here there is no requirement like that. So no software is required at client side or a server side, like, so that dependency is also gone. And from with respect to all the other driver, the performance is quite good, and hence the way in which I put it down, so hence it's a very widely used in all the enterprise applications. So E stands for enterprise applications. So in industry, the type 4 driver is very widely used, and we are going to see a code actual implementation using this type 4 driver. So in the next presentation we'll go more into the details about this JDBC, and then we'll slowly go towards the actual code base using type 4 driver, and our focus will be on type 4 driver. Thank you.